Expressions are a really useful way in order to be able to apply a mathematical equation or a mathematical sum function to part of the calibration you're active in. This is useful to be able to assign shortcuts and hotkeys, so to speak, in order to apply functions that you've saved from before. Now, this is quite popular for most people for a quick lambda function. This basically allows the ECU to say, look at the fuel multiplier closed loop lambda, which is the correction amount for your lambda control, and basically we'll look at how hard the lambda control is working to achieve that target. And this value here, which is currently 1, will be populated with different values and variation when the engine is running. So 0.8, 1.2 would mean it's adding 20% fuel. And what we can do with that is we can basically, when you're actually calibrating the fuel map, you can go via these cells, okay, and then you can just literally press F10 and apply a math expression to that cell. So let's go over how that's done. So under math, you've got the simple normal math functions that are under here, but we want to actually go to edit expression. Now currently, just for this example, what I've actually done is actually entered an expression already. So what we've got in here is we've got CV, which is for current value. So that was basically looking at the current highlighted point of this particular only table, not of every table that's active, only the current table that's active, which is now the base injection timetable. And what I've actually done is I'm just timesing it by fuel multiplier ECT1. We can change that, so you can, like, if you edit these values and take it back, it will bring up any items for you quickly as in the search function. But for us, we're just going to go ECT1. Apply that. Now what it's going to do is the current cell which I've got highlighted, which is here, basically when I press OK, it's going to actually ask me, do you want to run this expression now? So I'm going to say yes, and what it will also do is save that expression for next time, so I can just press F10 and it will do it on the next cell. So let's go yes, and you can see what it's done here is it's actually just added 10% to this cell, and you can see that in the top left here where it says 10%. That's the delta change on that particular cell. So I can then go to another cell, click here, and now just press F10 and it will apply the same function. Now if I press undo, U to undo that, what is really useful here is that now we can go to math edit expression and change this to fuel multiplier closed loop lambda 1, and what we can then do is basically it will then look at your fuel multiplier closed loop lambda adjustment, and automatically every time you press F10 automatically update the cell to that point, which is a really nice way of knowing what other systems call it as like a quick lambda. It saves time and is really useful. Now other ways the expressions are useful as well. Another thing I use it for is for the relative fuel pressure multiplier table. So let's just set this table 0 out for the minute. And what I'm going to do now is go over how I go about, say for example, sorting out a relative fuel pressure multiplier setup. Now, for example, the fuel pump is currently running on this car, and we've got the fuel pressure that's sitting around about 3.3. Now, I'm going to program the ECU, and what that's going to do is it's going to bring the fuel pump in again. And we can see there that now the fuel pressure is sat at 4 bar, which is our base pressure. Now from that we can go to math expression again, and in here you can actually see I've already got an expression which I use quite a lot. Now what I'm doing here is I'm taking the square root of the base pressure and then dividing it by the breakpoints. What this does is this will automatically populate like a linearization, so to speak, of the change in base pressure to suit the engine. Now if I say change this, we know our base pressure is at 4,000, so 4 bar. Change that to that, it will then divide this by the breakpoints, and you'll see what happens now. It will basically populate this table to have a curve so that when it's at 4 bar there's no relative fuel pressure being applied, trim, and then as you can see if the relative fuel pressure, which is the difference between your fuel pressure and your manifold pressure differences, so if you look at currently the relative fuel pressure here is at 3.5. If I was to simply go in and change my linearization for map sensor, you'll see the relative fuel pressure change. So you can see as the boost is increasing, if you haven't got a 1-to-1 ratio like on a reg, you'll see the relative fuel pressure will change, and you can change this under sensors for fuel pressure, and you can change the relative fuel pressure reference. So this would be the manifold pressure. So it's relative, the fuel pressure is relative to the manifold pressure, and when they differentiate then you can automatically apply fuel to that, which is a really useful function.